All right, everyone, welcome. So let's jump right in. Today, we're going to tackle a topic that I know for a lot of you might seem like just another required course you have to get through. But I want to change your perspective on that, because what we're covering today, linear functions, is truly one of the most foundational and, honestly, most powerful skills you're going to have in your entire business career. See, a linear function, at its heart, is just a simple way to describe a straight line relationship between two things. And in the world of business, that simple idea is the key. It's how we understand the way changes in one area, say how much we produce, directly affect another area, like our total costs. So this isn't about memorizing formulas for an exam. This is about learning to speak the language of business strategy.
Now, I know what you might be thinking. How can one simple line, a straight line, actually predict a company's future? It sounds like a huge exaggeration, right? But here's the thing. That line, that mathematical function, is what we call a model. And a model is just a simplified version of reality. In business, we rely on models to make sense of all the complex chaos, to understand the connections between our costs, our production levels, our revenue, and ultimately, our profit. The linear model is almost always the first, and I'd argue the most important one you will ever learn. It's the tool that lets you go from just guessing about the future to actually forecasting it. It's how we move from just hoping for success to building a real strategy to achieve.
So that's our mission for this session. We are going to move past the abstract theory you'd get from a textbook. We're getting practical. We're going to take a formula that you've probably seen before, y equals mx plus b, and we are going to transform it right here into your very first powerful tool for real-world business analysis. This little equation is the absolute bedrock for modeling these kinds of straight-line relationships. And I promise you, by the time we're done here, you'll be able to use it to build a fundamental financial model completely from scratch.
Okay, so before we can start building anything, we need to get our tools in order. And in the world of linear functions, we have two main forms that we use. Think of them as the two essential tools in your mathematical toolkit. Knowing what they are, and more importantly, when and why you'd use each one, is a really crucial part of the whole analytical process. So let's get them out on the table.
Now this is where it gets really interesting. This is where we stop thinking like math students and start thinking like business managers. We have to translate these variables into real business concepts. So on the left, you've got the point-slope form. This one is super useful when you find yourself in a very specific situation. You know one single data point. Like for example, you know for a fact that last month it cost you exactly $10,000 to produce 500 units. And you also happen to know the rate of change, your M, which might be the cost to make just one more unit. It's great for building an equation from a single known scenario. But for what we're doing today, and for most cost modeling you'll do in your career, we're going to focus on the real workhorse, the slope-intercept form, y equals mx plus b. This is where the magic really happens for business analysis, because here, m is no longer just an abstract slope. No, in our world, m is your variable cost per unit. It's the direct, tangible cost of producing one more item, the coffee beans, the packaging, the label. And b isn't just some y-intercept, it represents your fixed costs. These are the baseline costs you have to pay every single month: rent, salaries, utilities, even if you produce absolutely nothing. This form, y equals mx plus b, gives us a beautiful, complete, and immediate picture of a company's entire cost structure in one elegant little equation.
All right, enough with the theory. To make this really concrete, let's step out of the abstract and into a real-world scenario. We're going to build a cost model for a hypothetical coffee roasting business. And this isn't just some academic exercise. This is exactly the kind of fundamental analysis that any business owner, any manager, any entrepreneur has to do to really understand the financial health of their operation and to start making smart, informed decisions.
Okay, here's our raw data. Now, the first and most critical step is to correctly identify and separate our costs into two buckets, fixed and variable. Look at the table. Our fixed costs, the rent, the salaries, the basic utilities, these things do not change no matter how many bags of coffee we roast and sell. If you add them up, that's $5,500. We have to pay that $5,500 whether we sell one single bag of coffee or 10,000 bags. And understanding that number is so critical because it tells you the absolute minimum amount of money you have to make just to keep the lights on, just to break even. Then we have our variable costs. In our case, for every single bag of coffee we decide to produce, it costs us an additional $5. That's for the beans, the bag itself, the label, everything directly tied to that one unit. This distinction, the separation, is the absolute foundation of what we call cost-volume-profit analysis. It's what allows us to predict with amazing accuracy how our total costs are going to change as our production levels go up or down.
So, we have our data all sorted out. We have our favorite tool for the job, the slope-intercept form, y equals mx plus b. Now it's time to put them together. We are literally going to construct the equation that represents the entire cost structure of our coffee business. We're about to model a key piece of our company's financial reality.
Let's walk through this exactly how a business manager would, thinking it through out loud. Okay, step 1. I need to figure out my baseline. What are my fixed costs? What are the bills I have to pay every month, no matter what? All right, looking at my data, I've got $2,000 for rent, plus $3,000 for my staff, plus another $500 for utilities. So my B value is $5,500. Got it. Okay, step 2. Now what's my M? What's my variable cost for each unit? For every single bag of coffee I want to make, what's that extra little cost? The data tells me it's $5. Perfect. M equals 5. Okay, step 3. Now I just have to plug these two numbers into our slope-intercept formula. So y equals 5x plus 5,500. And just like that, we've built a financial model. So now let's go to step 4 and see what this thing can actually do. We can use it to ask and answer a real strategic question.
And here we have it. This is the beautiful result of our work. What we've created here is formally known as the total cost function. Let's really break down this equation one more time. The y on the left, that represents our total monthly cost, the final number we're trying to find. The x is the number of coffee bags we produce. That's our variable. The 5 multiplied by it is our variable cost for each of those bags. And that $5,500 at the end, that's our fixed cost that we have to pay every month, our starting point. This simple line of algebra now holds the financial DNA of our company's cost structure. We now have the power to predict our total costs for any level of production we can imagine. That is an incredibly powerful tool for planning, for budgeting, for just about everything.
Okay, so now it's time to put our model to work. Let's imagine the sales team just landed a huge order from a new corporate client. Or maybe we're just planning our production goals for next month. We need a precise answer to a very real question. If we decide we need to produce 1,000 bags of coffee, what is that going to cost us in total? Now, before we built this model, this might have involved a whole lot of guesswork or maybe a messy spreadsheet. But now, it's a simple, elegant question we can just plug directly into our function.
And there is our answer, $10,500. So how did we get that so fast? Well, it's simple. We just took our equation, y equals 5x plus 5,500, and we replaced the x with our production target of 1,000. So y equals 5 times 1,000, which is 5,000, plus our fixed costs of 5,500. Add them together, and you get $10,500. Now, stop and think about what this number actually means. We can now tell our new client how much this big order is going to cost us to fill, which is the essential first step in figuring out a profitable price to charge them. We can also use this number to create a detailed budget for the month, making sure we have enough cash on hand to cover all of our expenses. That right there is the power of turning data into a predictive tool.
Now listen, creating the model is one thing, but creating an accurate model is something else entirely. And this is where I see so many students, and to be honest, a lot of professionals out in the real world make mistakes. So let's spend a few minutes on the most common traps people fall into, because I want to make sure that the models you build are reliable and that they lead to good, sound business decisions.
The most important thing here is just paying attention to the details. First, and this is a big one, never mix up your fixed and variable costs. If you accidentally toss a variable cost, like the cost of your coffee beans, into your fixed cost calculation, your entire model is broken from the very start. Your B value, your y-intercept, will be wrong, and that will skew every single prediction you make. Second, be incredibly precise with your slope, your M. A really common mistake is to use the cost for a batch of items. Let's say your supplier sells you a big box of 100 coffee bags for $100. It is so tempting to use 100 as your M, but you can't. Remember, M has to be the cost for a single unit. So in that case, you'd have to divide. $100 divided by 100 bags means your M is actually $1. If you use the batch cost, you'll overestimate your variable cost by 100 times. And finally, and this is so critical as you move forward, never, ever confuse your cost function with your revenue function. They are two totally different things. You will build a separate linear function for revenue. It will likely look something like R equals P times X, where P is the price you sell each unit for. Mixing these up can lead to absolutely disastrous decisions. You might think you're making a profit on every sale, when in reality, you're actually losing money.
So let's just step back for a second and bring this all together. What we've been talking about today, this is not just a mathematical exercise. This is about you developing an analytical mindset.
It's about learning to see the underlying structure in a business, and that is a skill that will give you a real, tangible, strategic advantage for your entire career.
This quote just says it all, doesn't it? The relationship between cost, volume, and profit isn't just for the accountants to worry about. It's the absolute core of business itself. And our little cost function, our y equals mx plus b, is the mathematical story of that relationship. When you really get how to build and interpret this model, you're no longer just looking at a bunch of numbers on a spreadsheet. You're actually understanding the mechanics of how the business works. You can start to answer all of the critical what-if questions that drive good strategy. What if our landlord calls and says our rent is going up by $500 next month? Well, our B just went from $5,500 to $6,000, and we can immediately calculate how that affects our break-even point. What if our coffee bean supplier raises their prices by 50 cents a bag? Well, our M just went from $5 to $5.50, and we can calculate exactly how much that's going to increase our total costs at any production level. You can see instantly how these real-world changes are going to impact your bottom line.
So, I'm going to leave you with this final thought to take with you. I want you to project what we've learned today into your own future. It doesn't matter if you're going into marketing, finance, operations, or even if you want to start your own company one day. I want you to think, what is a key trend, a key relationship in your chosen field that you could model with a simple equation just like this one? Could you model the relationship between how much you spend on ads and how many new customers you get? Or maybe the cost of your inventory as a function of your sales volume? How about the growth in subscription revenue over time? The principles are exactly the same. The ability to see the simple, straight line hidden inside the complexity of business data, that is a superpower, and it's a skill that will serve you well for your entire career.